Hello everyone, welcome back to Maths Marathon classes. This time I'll be doing 2024 JEE Main complex numbers of April shift. Already I've done 2025, both January and April shift of this chapter. Now I'm doing 2024 April shift complex numbers, the first few topic, quite interesting topic. You see the number of questions appeared from different topics, different concepts of this chapter. Algebra of complex numbers, we have two questions. Modulus, conjugate, argument, 4 questions, maybe properties or such things, definition or modulus, definition of the properties of modulus, conjugate, argument, 4 such questions are asked. No questions are asked from De Moivre's theorem and cube roots of unity, nth roots of unity. We have geometrical representation, 4 questions, okay. Altogether we have 10 questions from this chapter. We'll discuss the questions one by one along with concepts. Alpha and beta be the sum and the product of all non-zero solutions of this equation. Z belongs to complex numbers. Want to find 4 times alpha square plus beta square equal to how much? The given equation is Z bar square plus mod Z equal to 0. So we'll take a complex number Z equal to x plus iy and substitute for Z bar and mod Z and solve the equation. Okay. So we'll take Z equal to x plus iy as usual. Let Z be equal to x plus iy. Let Z be equal to x plus iy, where I is root of minus 1 is understood. Mod Z is what? Mod Z is root of x square plus y square. Z bar represents conjugate. Conjugate is x minus iy. Real part you keep as it is. Change the sign of imaginary part. Z bar. Z bar is x minus iy, and mod z. Mod z is root of x square plus y square. Modulus root of real part square plus imaginary part square. Z bar square you have to find out. Then I'll substitute. Okay. Z bar square is what? Z bar square is x minus iy the whole square. If I expand this, x square plus I square y square minus 2xyi, correct? And use the fact that I square is equal to minus 1. So I am going to get x square minus y square, x square minus y square minus 2xyi. So substitute for z bar square and mod z. The given equation becomes z bar square. Z bar square I got like this. X square minus y square minus 2xyi. The given equation becomes, the given equation is x square minus y square, x square minus y square minus 2xyi plus mod z is root of x square plus y square. Root of x square plus y square is equal to 0. 0 means you can write it as 0 plus I into 0, correct? So two complex numbers are equal if their real parts are equal and their imaginary parts are equal. We know this. So 0 I can write 0 plus I into 0 and equate the real parts and equate the imaginary part. Real part is without I. Terms without I is real part. X square minus y square plus root of x square plus y square, that is real part. 0 of course you can write it as 0 plus I into 0. Equating the real and imaginary parts. What I am going to get from this? X square minus y square plus root of x square plus y square is equal to 0. Equating the real part to 0. And imaginary part. The term associated with I is called imaginary part. The term with I is minus 2xy. That should be equal to 0, correct? So equating the imaginary parts and I write. And minus 2xy should be equal to 0. Minus 2xy should be equal to 0. Minus 2 can't be 0. So xy should be equal to 0. Xy 0 means either x equal to 0 or y equal to 0. You know this. X into y is equal to 0. This implies either x is equal to 0 or y is equal to 0. Either x equal to 0 or y equal to 0. When x equal to 0, substitute this. Find the corresponding value of y. I need to find the solutions. I'll find out the non-zero solutions of this equation by solving this. I've taken z equal to x plus iy. Z bar is conjugate x minus iy. Modulus of z is root of x square plus y square. All those things we're going to substitute. The given equation becomes like this. And equate the real parts and equate the imaginary parts. We get two equations like this. X into y is 0 means either x equal to 0 or y equal to 0. When x equal to 0, substitute this. When x equal to 0, what happens? We get the corresponding value of y. When x is equal to 0, this equation becomes 0 square, correct? This equation becomes 0 square minus y square plus root of x is 0, 0 square plus y square is equal to 0, correct? Minus y square, root of y square is mod y, root of y square is mod y equal to 0. Now I'll discuss two cases because there is modulus of y. Don't write root of y square as y, it will go wrong. Root of y square is mod of y. I need to discuss two cases. Y is greater than or equal to 0, one possibility, and y less than 0, correct? Whenever there is modulus function, we discuss two cases. Case 1, y is greater than or equal to 0. In that case, what do you get? Y is greater than or equal to 0. Mod y becomes y. So this becomes minus y square plus y is equal to 0. You can take y common. Y into 1 minus y equal to 0. This gives either y equal to 0 or y is equal to 1. Either y equal to 0 or y equal to 1. So when x is 0, y is 0. That's not possible because 0 plus I 0 is not there because it was non-zero solution. Don't take x equal to 0, y equal to 0. I can take x equal to 0, y equal to 1. One possibility. Case 1. Case 2 for this. Case 2 when y is less than 0. Case 2 for y less than 0. For y less than 0, mod y becomes minus y, correct? Minus y square. Mod y becomes minus y is equal to 0. You can take minus y common. What remains is y plus 1 equal to 0. A into b 0 means either a equal to 0 or b equal to 0. Y equal to 0 or y equal to minus 1. So when x is 0, y equal to 0 I won't take because 0 plus I into 0 is 0 complex number. I want a non-zero complex number, non-zero solution. Don't take 0, 0. I'll take 0, 1. X equal to 0, y equal to 1 is possible, correct? Therefore, z becomes 0 plus I into 1 from this. X equal to 0, y equal to 1 is possible. When x equal to 0, y is minus 1 is possible. Don't take again 0 here. 0 plus I into 0 is not possible because we want non-zero solution. Here I get z is equal to x is 0 plus I into y is minus 1. Two solutions we got from this. Taking x equal to 0. Correct? When x equal to 0, I got two solutions. Now find when y equal to 0. This case is over. Now come to this case. When y equal to 0. When y is equal to 0, what happens? This equation becomes what? Consonant of this equation. When y is equal to 0. When y is equal to 0 becomes x square minus y is 0. 0 square is 0 plus root of x square plus y is 0. 0 square is 0 equal to 0. Again, root of x square is mod x. Again, x square plus mod x equal to 0. I need to discuss two cases because there is modulus function. Mod x. Case 1, x greater than or equal to 0. Correct? I'll discuss here itself. Case 1 for this. Case 1, when x is greater than or equal to 0. If x is greater than or equal to 0, this equation becomes x square plus x equal to 0. Mod x is x for x greater than or equal to 0. Correct? So I get x square plus x equal to 0. x is common. 1 plus x equal to 0. A into b is 0 means either a equal to 0 or b equal to 0. X equal to 0 or x equal to minus 1. Correct? 0 when y is 0, x is 0 not possible because 0 plus I into 0 becomes a 0 solution. We want non-zero solution. When y is 0, x is minus 1 is not possible because x is greater than or equal to 0. Both the values are not possible. Case 2, when when x is less than 0. X is less than 0. Mod x becomes minus x. Referring to this equation, x square minus x equal to 0. X is common. X into x minus 1 equal to 0. This gives either x equal to 0 or x equal to 1. X equal to 0 or x equal to 1. When y is 0, x equal to 0 not possible. 0 plus I into 0 is 0 solution. We want non-zero solution. If you take x equal to 1, y equal to 0, that's also not possible because I'm discussing case x less than 0. X less than 0 means x equal to 1 is not possible. So both the solutions are not possible here. Here no solution I get. Here only solution I get is one is here. 0, z equal to 0 plus I into 1 and z equal to 0 plus I into minus 1. Only two solutions I get. That is I and minus I. 0 plus I into 1 is I. 0 plus I into minus 1 is minus I. Two solutions I got. Alpha is sum of all the non-zero solutions. So take the sum of all non-zero solutions. And beta is the product of all non-zero solutions. Therefore, I can write alpha as what? The sum of all non-zero solutions. Alpha is equal to. Non-zero solutions are I and minus I. So I plus minus I. I plus minus I, which is equal to 0. And beta is the product of all the non-zero solutions. I into minus I. Non-zero solutions are I and minus I. So beta is the product of all non-zero solutions. I into minus I becomes minus I square. Minus I square is plus 1. I square is minus 1. Minus I square is plus 1. We need to find 4 times alpha square plus beta square finally. Therefore, my final answer is going to be 4 times using this. Therefore, 4 times alpha square plus beta square is equal to how much? 4 times alpha is 0, 0 square 0, beta is 1, 1 square 1. Therefore, I get the answer as 4 into 1 equal to 4. So, required answer is option D. Question asked on 4th of April, first shift, JEE Main 2024. Quite a simple question. This type of question is commonly found in many papers. Take z equal to x plus iy, z bar is x minus iy, mod z is root x square plus y square, square it, add it, okay, all those things. Then discuss various cases, we'll get the solution. Two solutions we got, I and minus I. Alpha is sum of the solutions, sum of the non-zero solutions, I plus minus I, 0. Beta is the product of the non-zero solution, I into minus I square is plus 1. So alpha is 0, beta is 1. Substitute in this, get the answer. 4 times alpha square plus beta square. That is what they asked to find. 4 times 0 plus 1. 4 into 1, 4 is the answer. Hope it's clear. Move on to the next one. The area of the region S is given like this. Okay, there are 3 conditions given here. Mod z minus 1 less than or equal to z plus z bar plus I into z minus z bar is less than or equal to imaginary of z is greater than or equal to 0. First of all, you must know that mod of z minus z naught less than or equal to r, mod of z minus z naught less than or equal to r represents the points on the circle and interior to circle having center at z naught and radius is r. Okay, so mod of z minus 1 less than or equal to 2 represents circle having center at 1 comma 0, z naught is 1, 1 means 1 plus I into 0, so center is at 1 comma 0, radius is 2, points on the circle and interior to circle. So that will represent. This is a question based on the geometrical representation of a complex number. Okay, so z plus z bar, that is 2 times real part of x, real part of z, 2x second, right? Z minus z bar is 2iy, 2i imaginary part of z. I can simplify. So mod z minus 1 less than or equal to r, given mod of z minus 1 less than or equal to r represents the points on the circle and interior to circle having center at z naught. Z naught is 1, radius is how much? 2, given less than or equal to 2. mod z minus 1 less than or equal to represents points on the circle and interior to circle. Points on the circle and interior to circle. With center at 1 comma 0 and radius is 2. With center at 1 comma 0 and radius is 2. You must know this. Mod of z minus z naught less than or equal to r represents the center at circle with center at z naught and radius is 2. Radius is 2. Radius is 2. Center at 1. Z naught is 1. 1 means 1 plus I into 0. 1 plus I into 0 can be represented as a point 1 comma 0. So z minus z naught, compare, z naught is 1. Mod of z minus z naught less than or equal to r represents circle with center at z naught, radius r, points on the circle and interior to circle. So representation of this. Next one we got z plus z bar plus I into z minus z bar less than or equal to. We'll solve that. Z plus z bar and z minus z bar we know already. So z plus z bar plus I into z minus z bar less than or equal to 2. Correct? Z plus z bar is 2x. I into z minus z bar is 2iy using properties of conjugate. And use the fact that I square is minus 1. I square is minus 1 and also will divide the entire inequation by 2. If you divide by 2, you'll get x minus y less than or equal to 1. Because I square is equal to minus 1. I square is minus 1 and dividing by 2. Imaginary of z greater than or equal to 0. If you take a complex number z equal to x plus iy, x is real part, y is imaginary part. Imaginary of z greater than or equal to 0 means y is greater than or equal to 0. And imaginary part of z is greater than or equal to 0 implies y is greater than or equal to 0. Y equal to 0 is the equation of x-axis. Y greater than or equal to 0 is points on the x-axis and above the x-axis. Okay. Imaginary part of z. Z is x plus iy. Imaginary part of z is y. Correct? If you take z equal to x plus iy as a complex number. Imaginary part of z is y. Y is greater than or equal to. Y equal to 0 is equation of x-axis. Y greater than or equal to 0 is points on the x-axis and above the x-axis. So we'll solve these. Okay. So we'll represent this and find the common region for all these things. Then you have to find area of that. So 3 inequations I got. One is this. Mod z minus 1 less than or equal to. One is this. Another is here. X minus y less than or equal to 1. This is second one. And third one is this. Y is greater than or equal to 0. 3 things will represent. Represent these 3 things. Okay. Circle with center at 1 comma 0. Radius is 2. Circle with center at 1 comma 0. 1 comma 0 is here. And radius is 2 units. So it will pass through the point here. 3 comma 0 will be the one end of the diameter. And minus 1 comma 0 is the other end of the diameter. Correct? So circle will be something like this. Circle is having the endpoints of diameter as minus 1 comma 0 and 3 comma 0 because radius is 2. You can shift 2 units here, correct? Radius is 2. Something like this. Circle is center at 1 comma 0. 1 comma 0 is the center. This is origin. This is minus 1 comma 0. This point is minus 1 comma 0 and this point is 3 comma 0. Okay. 1 comma 0 is the center of the circle. Radius is 2. The first one I represented. Now represent x minus y less than or equal to 1. Draw the line x minus y equal to 1. You can write x minus y equal to 1 as x by 1 plus y by minus 1 equal to 1. Correct? X minus y equal to 1. X minus y equal to 1 can also be written as x by 1 plus y by minus 1 equal to 1. Correct? That means x-intercept is 1, y-intercept is minus 1. X-intercept 1 means it passes to the point 1 comma 0. And y-intercept is minus 1, somewhere here. Minus 1, correct? 0 comma minus 1. 0 comma minus 1. Circle has center at 1 comma 0 and the line is x by 1 plus y by minus 1 equal to 1. It passes through 1 comma 0 and also passes through 0 comma minus 1. 0 comma minus 1, does it satisfy the equation of circle? 0 minus 1 is 0 comma minus 1 is here, correct? So line is like this, passing through these 2 points. These 2 points it passes. This is 1 comma 0 take, okay? So line is something like this. This line x minus y equal to 1. X minus y equal to 1 is this. If you only can write the equation of circle in the Cartesian form as x minus 1 the whole square plus y minus 0 the whole square equal to 2 square, which is 4. This is the equation of circle in the Cartesian form, okay? That means 0 comma minus 1 does not lie on the circle, I think, correct? 0 comma minus 1, if you put x equal to 0, y equal to minus 1, minus 1 square 1. I should draw a little bit above, I think, correct? 0 comma minus 1 does not lie on the circle. Just a minute. Small correction with the line there. Representation of line is not so accurate here. Something like this. The equation of line is passing through the point 0 comma minus 1. It does not lie in the equation of circle, so represent like this. And we want to shade x minus 1 less than or equal to 1. Does 0 comma 0 satisfy this? Put x equal to 0, y equal to 0. 0 minus 0. 0 less than or equal to 1 is true. Inequality is true for 0 comma 0. So region is towards the point 0 comma 0. So we want points on the circle and interior to circle, and it is above the line, correct? Above the line x minus y equal to 1, correct? Because x minus y less than or equal to 1, 0 comma 0 satisfies. 0 minus 0, 0 less than or equal to 1, correct? Inequality is true. 0 less than or equal to 1, inequality is true. Therefore, it is towards 0 comma 0. So this line is going up, and we want inside the circle, points on the circle and inside the circle. And y is greater than or equal to 0. Y equal to 0 is the equation of x-axis. Y greater than or equal to 0 is points on the x-axis and above the x-axis. So common for all the three, inside the circle, above this line and above the x-axis. That will be this part. This part, correct? This is a required region. Want to find the area of this region. Want to find area of this. So to find area of this region, what I'll do is find area of the semicircle and subtract this part. Area of the semicircle is half of the area of the circle. Area of the circle we know, pi r square. Area of the semicircle is pi r square by 2. Radius is 2, correct? So required area is pi r square divided by 2 minus area of this sector. To find area of the sector, I am using this formula, half r square theta. Area of the sector is half r square theta. Half r square theta. Half into radius of the circle is 2, so 2 square. Theta is this angle. What is slope of this line you find out? Slope of the line is minus coefficient of x by coefficient of y. X minus y equal to 1. From the equation of line I can find its slope. Slope of this line is minus coefficient of x by minus coefficient of x1, correct, divided by coefficient of y is minus 1. Slope is 1. Slope is tan theta. Tan theta is 1 means theta is pi by 4. So theta is pi by 4 here. 2 square 4, 4, 4 cancels. What I am getting is pi by 2 here. So area of the sector is pi by 2. Here I can substitute pi into radius is 2. 2 square 4 divided by 2 minus pi by 2. 1, 2 will cancel. I get 2 pi minus pi by 2. 2 pi minus pi by 2 which is equal to 3 pi by 2. Answer is option D. So many concepts are there here. Finding area of the common. First you have to find the common region for the three equations given here and find its area. Area of the semicircle minus area of the sector. This angle is pi by 4 here. Also we need to know the concept of slope here. Slope of this line is minus coefficient of x by coefficient of y. Coefficient of x1, coefficient of y is minus 1. Minus 1 by minus 1. Slope is tan theta. Tan theta 1. So theta is pi by 4. So substitute area of the sector half r square theta. Again radius is 2. 2 square 4. 4 4 cancels. Pi by 2 is area of the sector. Area of the semicircle minus area of the sector will give the shaded part. Answer is 3 pi by 2. Hope it's clear. So remember this, mod of z minus z naught less than or equal to r represents points inside the circle and on the circle having center at z naught and radius is 2. Correct? Z naught is 1. 1 means 1 plus I into 0 which is 1 comma 0. Every complex number x plus iy can be represented as an ordered pair x comma y. So z naught is 1. 1 means 1 plus I into 0. So center is 1 comma 0 and radius is 2. Equation of circle if you want you can write in the Cartesian form. And here z plus z bar is 2x. Z minus z bar is 2iy. Use the fact that I square equal to minus 1. Divide by 2 and write. Imaginary part of z is greater than or equal to 0. If you take a complex number z equal to x plus iy, real part is x, imaginary part is y. So y is greater than or equal to 0. So represent common region you find out and find area. Question asked on 4th of April, second shift, JEE Main 2024. Move on to the next one. Consider the following two statements given. Statement 1. For any two non-zero complex numbers z1, z2, we got like this. And statement 2 is also given like this. Verify. Statement 1 is true or not. Statement 2 is true or not. Statement 1. See, this looks like a triangle inequality. Correct? Already we know the triangle inequality. What is triangle inequality says? For z1 and z2, any two complex numbers, we have mod of z1 plus z2 less than or equal to mod z1 plus mod z2. By triangle inequality, by triangle inequality, what we have? Mod of z1 plus z2 is less than or equal to mod z1 plus mod z2. This is the triangle inequality for all z1, z2 belongs to C. Correct? So I'll apply triangle inequality for this. Mod of z1 by mod z1 plus z2 by mod z2. For that I'll apply triangle inequality. In place of z1, you take z1 by mod z1. z1 by mod z1 is a complex number. z2 by mod z2 is another complex number. So I'll take instead of z1, z1 by mod z1. z1 by mod z1. I'll take z2 as z2 by mod z2. For this, if you apply the triangle inequality, what do you get? z1 by mod z1 is my first complex number. z2 by mod z2 is my second complex number. Applying triangle inequality for this, what do you get? Mod of z1 by mod z1 plus mod of z2 by mod z2. Like this you get. Mod z1 by mod z1. This becomes 1. See, this denominator is already a real number. Correct? And that too is positive. Mod is not required for this. Mod of mod z1 is same as mod z1. If you take modulus once or twice, it is same as taking once. Correct? mod of mod z1 is same as mod z1. After taking modulus for a complex number, it becomes a real number, and that way it is positive or 0, and anyway it's non-zero here, correct? So denominator is not 0, correct? So mod of mod z1 is same as mod z1. This becomes mod z1 by mod z1. This is what? Mod z1 divided by mod z1 plus this is mod z2 divided by mod z2, correct? This becomes 1 plus 1 is equal to 2. So we got mod of z1 by mod z1 plus z2 by mod z2 is less than or equal to 2. So statement 1 is correct because I can multiply both sides by mod z1 plus mod z2. Mod z1 plus mod z2 is positive number because it's non-zero, it's positive, correct? So I'll multiply. What I got so far is mod of z1 by mod z1 plus z2 by mod z2. This is less than or equal to 2 I got. Now I'll multiply both sides by mod z1 plus mod z2. Hence the statement 1 is true. Mod z1 plus mod z2 will multiply both sides. This is z1 by mod z1 plus z2 divided by mod z2 is less than or equal to 2 times. This we already established. I am multiplying both sides of the inequation by mod z1 plus mod z2. Correct? Multiply both sides by mod z1 plus mod z2. Hence, statement 1 is true. First I establish this. Mod of z1 by mod z1 plus z2 by mod z2 less than or equal to. Then multiply both sides of the inequation by mod z1 plus mod z2. Hence, statement 1 is true. Statement 1 is true. What about statement 2? The given x, y, z are three distinct complex numbers. A, B, C are three positive real numbers such that A by mod of y minus z equal to B by mod of z minus x equal to C by mod of x minus y. Then whether this statement is true or not, I have to verify using this condition. A, B, C are three distinct positive real numbers. X, Y, Z are three distinct complex numbers. X, Y, Z are three distinct complex numbers. A, B, C are three positive real numbers. Okay. So let A by mod of y minus z be equal to x. Okay. The given A by mod of y minus z is equal to B by mod of z minus x is equal to C by mod of x minus y. Okay. Let it be equal to lambda. So A will be lambda into mod y minus z. From this, say, let it be equal to lambda, some positive real number. Okay. So A will be how much? From this, A is equal to lambda times mod of y minus z. So if you do squaring on both sides, A square is how much? A square is equal to lambda square into mod of y minus z the whole square. Correct? And I can write this as lambda square into y minus z square. Mod of y minus z square is y minus z into y minus z the whole bar. Correct? Because we have mod z square is equal to z into z bar using the property of modulus. Mod of z square is z into z bar. So mod of y minus z square is y minus z into y minus z conjugate. So from this I can find out what is a square by y minus z. So what is a square by y minus z from this? A square divided by y minus z is how much? Lambda square into y bar minus z bar. Correct? A square by y minus z I got. Similarly, if I equate b by mod of z minus x equal to lambda, b by mod of z minus x is equal to lambda, I'll get b is equal to lambda into mod of z minus x. Squaring here, b square is equal to lambda square into mod of z minus x square, which is lambda square into mod z minus x square is z minus x into z minus x the whole bar. Correct? Z bar minus x bar, right? So I can find out what is b square by z minus x. What is a square by y minus z I got? A square by y minus z I got. Lambda square into, I'll write here, lambda square into y bar minus z bar. What is b square by z minus x? From this b square by z minus x is lambda square into z bar minus x bar. I am finding out the second term. B square divided by z minus x is lambda square into z bar minus x bar. Same way I can find out, equating these two, cross multiply and square on both sides. I'll get c square by x minus y as, from this cross multiply and do squaring on both sides and simplify. We'll get c square by x minus y as lambda square into x bar minus y bar. Correct? So that you can take lambda square common. And what remains inside the bracket is y bar minus z bar plus z bar minus x bar plus x bar minus y bar. Will cancel, become 0. X bar minus x bar will cancel. This and this will cancel. Correct? Y bar minus y bar will cancel. Z bar minus z bar will cancel. Sum will be equal to 0. So this expression simplifies to 0. A square by y minus z plus b square by z minus x plus c square by x minus y simplifies to 0 and it's not equal to 1. So that sum is equal to 0. That means statement 2 is incorrect. Statement 1 is correct, statement 2 is incorrect. Statement 1 is correct and statement 2 is incorrect. Option C. Question asked on 5th of April, first shift, JEE Main 2024. Hope it's clear. Till here we have statement 1, okay? Using triangle inequality, replace z1 by z1 by mod z1, replace z2 by z2 by mod z2, apply triangle inequality. This will cancel out. Numerator same as denominator, cancel out. 1 plus 1, 2. Multiply both sides by mod z1 plus mod z2, because mod z1 plus mod z2 is positive real number because it's non-zero. Modulus will be either positive or 0. It's non-zero here. So modulus is going to be positive here. Multiply both sides of the equation by a positive number. Inequality remains the same. Inequality remains the same. So statement 1 is true. The first part is done by using the triangle inequality and multiply both sides by mod z1 plus mod z2. Second part of the second statement I am verifying. Take this as lambda, cross multiply, squaring on both sides, okay, and use the property z bar, mod z square is z into z bar. Mod z square is z into z bar. Mod y minus z square is y minus z into y minus z bar. Y minus z bar is y bar minus z bar. From this we find out a square by y minus z, because we have a square by y minus z. A square by y minus z defined out. B square by z minus x from this. C square by x minus z. Everything will add up to 0. It's given to be equal to 1. It's not true. Statement 1 is correct. Statement 2 is incorrect. Option C is the answer. Move on to the next one. Question number 4. Z belongs to complex number mod z less than or equal to 5. Set 1. S1 is given like this. S1 is given that mod z less than or equal to 5. Mod z less than or equal to 5 represents points on the circle and interior to circle. Center at origin, radius is 5. Okay. Points on the circle and interior to circle. Points on the circle and interior to circle. And interior to circle. With center at origin, correct? Because mod of z means z minus 0, correct? Center at origin 0 comma 0 and radius is 5 units. First part is over. Second part, we need to solve this. Imaginary part of z plus 1 minus root 3i by 1 minus root 3i is greater than or equal to 0. So you take z as a complex number, x plus I, y, and substitute there. Consider the expression z plus 1 to solve this. S2, correct? Imaginary part of z, you take x plus iy. X plus iy plus 1 minus root 3i divided by 1 minus root 3i Here I'll multiply and divide by the conjugate of denominator. Multiply and divide by 1 plus root 3i. This entire thing should be greater than or equal to 0. I'm finding imaginary part of this greater than or equal to 0. Denominator is a minus b into a plus, which is a square minus b square. 1 square 1 minus root 3 square 3 I square. Correct? Denominator is a minus b into a plus b. That becomes 1 plus 3, 4. And imaginary part, where I'm getting imaginary part, only such terms to write. Where you get imaginary part, only that term I'm going to write here. So this im I'm not writing here. This im is not required. Where I'm getting imaginary part, only that I'll write. X into 1, x, that is the real part. Iy into 1, iy, imaginary part is y. 1 into 1, I won't write. Root 3 I into 1, minus root 3 I into 1, that is minus root 3. Imaginary part is there. Terms with I only I am writing, correct? X into 1 I won't write because that is real part. Iy into 1, y is the imaginary part. 1 into 1 I won't write, that's a real number. Root 3 I into 1, root 3 I. So imaginary part is root 3, that is minus root 3. Next, x into root 3 I, I'll get imaginary part there, root 3x. Next, I into I square is minus 1, I won't write. 1 into root 3i, imaginary part I'll get there, root 3, correct? Root 3. And root 3i, this becomes I square is minus 1, that will be real number, so I won't write that. So only this much is left, denominator is 4, correct? And minus root 3 plus root 3 will cancel out. This becomes, denominator is 4, here minus root 3 plus root 3 will add up to 0. What I am getting is root 3x plus y divided by I square is minus 1, 1 minus 3 into minus 1, 1 plus 3, 4. This is greater than or equal to 0. Denominator is already positive, so numerator should be greater than or equal to 0. Root 3x plus y greater than or equal to 0. Second one is over. And third one, S3 is given as real of z is greater than or equal to 0. If you take z as x plus iy, real part of z is x. So S3 is real part of z greater than or equal to 0. Real part of z is x. X is greater than or equal to 0. So we have to find the region, area of the region. S1 intersection, S2 intersection, S3. Find the common region for all these things. Represent S1 first. Points on the circle and interior to circle. Center at origin, radius is 5. We'll represent this. Points on the circle and interior to circle. Center at origin, radius is 5. Center at origin, radius is 5. This is the set S1. Points inside the circle and on the circle, and center at origin, radius is 5. First part is over. Second part, S2. Represent this. S2 is here. Correct? It's a straight line passing through the origin. Y is equal, I can write this as, if you take y plus root 3x equal to 0, that will be y equal to minus root 3x. Correct? Y equal to mx form with negative slope. If we compare with y is equal to mx, y is equal to mx if we compare, slope is negative, right? Slope is how much? Minus root 3. So negative slope means it makes an obtuse angle. If we compare with y is equal to mx, correct? Slope is minus root 3. Slope is tan theta. Tan theta is minus root 3, means theta is 120 degree. As you know, tan 120 degrees minus root 3. So I should draw the straight line y equal to minus root 3x. Y equal to mx means straight line passing through the origin. Slope is negative, means the line is making obtuse angle. Theta is 120 degree. Slope is minus root 3. Slope is tan theta. Tan theta is minus root 3. Theta is 2 pi by 3 or 120 degree. So I'll represent the line passing through the origin, which makes an angle of 120 degree with the positive x-axis. Something like this. This line is y equal to minus root 3x. We want y plus root 3x greater than or equal to 0. It's not a straight line, it's a region. Whenever they give inequality, it represents a region. So y plus root 3x greater than or equal to 0 means it is, we should find out whether it is above the line or below the line. Okay, we'll take a convenient point. We don't take 0, 0 here because the line is already passing through 0, 0. We can't take 0, 0. We'll take a convenient point, say 1, 0. The test. Put x equal to 1, y equal to 0. When you put x equal to 1, root 3 into 1 is root 3, y is 0, correct? Root 3 plus 0, root 3 is greater than or equal to 0 is true. Inequality is true if you take the point 1 comma 0. If you take a point 1 comma 0, inequality is true. So graph will be towards the point 1 comma 0. 1 comma 0 is 0. So it is above the line. This line is y plus y is equal to minus root 3x. This line is y equal to minus root 3x. We want y plus root 3x greater than or equal to 0. It is above the line. Okay. And x greater than or equal to 0. X equal to 0 is the equation of y-axis. X greater than or equal to 0 is right side of y-axis. So inside the circle, on the circle and inside the circle, above this line, and it is right side of y-axis. So my region is this. Correct? X greater than or equal to 0. X equal to 0 is the equation of y-axis. X greater than or equal to 0 is right side of the y-axis. Points on the y-axis and right side of y-axis above this line, inside the circle and on the circle. So region is this. This is S1 intersection, S2 intersection, S3. So find out area in the first quadrant of the circle and also area of the sector. Required area is 1/4 of the area of circle, quadrant of circle. Area of circle is pi r square. This is area of the quadrant of circle, pi r square by 4. Radius how much? Radius is 5, correct? So pi r square by 4. Pi r square divided by 4 plus area of the sector, half r square theta. Half r square. This angle is how much? This total angle is 120, correct? This angle is 120 degree. This line is making an angle of 120. So this angle becomes 60. 60 is pi by 3. So half r square theta. Half into r square theta is pi by 3. Find out this. Do the calculation and get the answer. Because this line is making an angle of 120 with positive x-axis. 120 is 2 pi by 3. This angle is pi by 3. Correct? Because linear angle is 180. So this is how much? 25 pi by 4 plus this is 25 pi by 6. Take LCM. 4 and 6 LCM is 12. 4 3s are 3 into 25 is 75 pi. 6 2s are 2 into 25, 50, 50 pi. So we get the answer as 125 pi by 12. 125 pi by 12, option A. Hope I understand this. How to find the common region and find the area of that common region. Area of the quadrant of the circle means 1/4 of area of the circle, pi r square by 4 plus area of the sector, which is half r square theta. R is pi, theta is pi by 3. Because this line is making an angle of 120 with x-axis. This much angle is 120. Correct? If you want, I can represent using some other ink. This angle is 120. This much is 120 degree. And this angle is 60 degree. Okay? This angle is required. 60 degrees pi by 3. This area I am finding out, area of the sector. Area of the sector is half r square theta. This angle is 120. This angle is 60. So 60 is pi by 3. I use it and get the answer. Question asked on 5th of April, second shift, JEE Main 2024. On to the next one. Z1 and Z2 are two distinct complex numbers satisfying this. Which of the following is true? You should see. Here, this question is based on one of the standard results. Okay. I'll mention the result here. It's a very important result. While I'm doing the synopsis, I'll be explaining all those things, how it is derived. For time being, I'll just mention the result. The result is that if alpha and beta are the two different complex numbers with either mod alpha is 1 or mod beta is 1, then we have one result. So one of the standard result we have. If alpha and beta are two different complex numbers, alpha and beta are two different complex numbers. are two different complex numbers with either mod alpha is 1 or mod beta is 1. Either mod alpha is equal to 1 or mod beta is 1. Then what we have is mod of alpha minus beta by 1 minus alpha bar beta is 1 or 1 minus alpha into beta bar is 1. Both are true. Okay. This will be true. Even this is true. Mod of alpha minus beta divided by 1 minus alpha bar into beta is equal to 1. Both will hold good. So remember this result. It's a very standard result. Already this kind of question was asked in 2015 JEE main. Okay. And this is again in the year 2024. 2 times appeared on this result. So to solve this problem, I'll be using this result. So if alpha and beta are two different complex numbers with either mod alpha 1 or mod beta 1, then what we have is mod of alpha minus beta by 1 minus alpha into beta bar is 1. And even mod of alpha minus beta by 1 minus alpha bar beta is 1. Both holds. Condition is either mod alpha is 1 or mod beta is 1 for this expression to hold. Okay. So I will be using this now. This expression is comparable to this. This is comparable to this. Slightly modified from the given. So I will rewrite this. I will take LCM in the denominator here first. 2 LCM. So given equation is mod of Z1 minus 2Z2 divided by half is there. No? I'll take LCM there. I'll write this as 1 minus 2Z1 into Z2 bar, correct, divided by 2 is equal to 2. This 2 will go up. Denominator goes to numerator. And that 2 is positive. I'll keep outside the modulus. 2 is anyway positive. So what is left is mod of Z1 minus 2 times Z2 divided by 1 minus Z1 into, I'll write this as 2 into Z2 bar. Conjugate of 2 is 2 itself. Correct? Is equal to 2. 2 cancels on either side. So what I'm going to get is mod of Z1 minus 2Z2 divided by 1 minus Z1 into 2 times Z2 bar is equal to 1. This is comparable to this. Compare these two. In place of alpha, we have Z1. In place of beta, we have 2Z2. You can put bar for this entire thing, no problem. Correct? Bar you can put for 2 also. 2 bar is 2 only. Conjugate of 2 is 2 itself. So this is comparable, correct? Alpha is Z1 and beta is 2Z2. Compare this equation with this. Exactly same. Where alpha is Z1 and beta is 2Z2. Alpha minus beta. Mod of alpha minus beta. Sorry, here it should mod, right? Here it is mod. Mod of alpha minus beta by 1 minus alpha into beta bar equal to 1. This condition holds when either mod alpha is 1 or mod beta is 1. Instead of alpha, what we have? Z1. This holds either when mod Z1 is 1 or mod of 2Z2 is equal to 1. This expression holds when either mod alpha is 1 or mod beta is 1. Instead of alpha, we have Z1. Instead of beta, we have 2Z2. Either mod Z1 is 1 or mod of 2Z2 is 1. Correct? Hope understand. Alpha is Z1 and beta is 2Z2. Compare this with this. Alpha is Z1. Beta is 2Z2. So mod of Z1 equal to 1 or mod of 2Z2 equal to 1. From this, what I can write here? Mod Z1 is 1. That you keep as this. 2 we can keep outside. From this I can write mod Z2 is equal to half. So this represents what? Mod Z1 equal to 1 represents a circle with center at origin, radius 1. Mod Z2 equal to half represents circle with center at origin, radius half. So either Z1 lies, I can tell Z1 lies on a circle with radius 1 or Z2 lies on a circle with radius half. That's the answer. Either Z1 lies on a circle of radius 1 or Z2 lies on a circle of radius half. So answer is option D. Hope it's clear. Learn this result and you can solve this question in very less time. Time saving result. Alpha and beta are two different complex numbers or two distinct complex number with either mod alpha is 1 or mod beta is 1. Then what we have is mod of alpha minus beta by 1 minus alpha into beta bar equal to 1. Also we have mod of alpha minus beta by 1 minus alpha bar into beta is 1 or alpha into beta bar is 1. Both will hold good. I'm using the first case and getting the answer. Hope it's clear. Take LCM as 2 here, that 2 will go up, that 2 cancels here. So right answer becomes 1. Compare alpha is Z1, beta is 2Z2, get the answer. Question asked on 6th of April, second shift, JEE Main 2024. Move on to the next one. Z is a complex number such that mod of Z plus 2 is 1 and imaginary part of Z plus 1 by Z plus 2 is 1 by 5. To find the value of mod of real of Z plus 2 bar. So whenever they give mod Z equal to R, now we can write Z as R into cos plus I sin. Use this technique. If they give mod Z is equal to R, if they give mod Z equal to R, I can write Z as R into cos theta plus I sin theta. Quite useful, okay. Here instead of mod Z equal to R, the given mod Z plus 2 is 1. Mod Z plus 2 is 1. So I can write Z plus 2 as, since mod of Z plus 2 is 1, since mod of Z plus 2 is 1, I can write Z plus 2 as Z plus 2 is equal to 1 into cos theta plus I sin theta. Okay, you can write like this. Mod Z is R means Z is R into cos plus I sin. You can write C as cos and S as sin. Short forms can be used. Okay, so Z plus 2 is cos plus I sin. 1 into cos plus I sin. And another equation is given. Imaginary part of Z plus 1 by Z plus 2 is 1 by 5. So from this Z is equal to how much? Z is equal to cos theta minus 2 I can write. Correct? Cos theta minus 2 plus I sin theta. Now take this imaginary part of Z plus 1 by Z plus 2 equal to 5. Now imaginary part of Z plus 1 divided by Z plus 2 is equal to 1 by 5. This is imaginary part of, what is my Z? Cos theta minus 2 plus I sin theta, correct? Cos theta minus 2, cos theta minus 2, Z is cos theta minus 2, cos Z plus 1 will be how much? Z plus 1 will be cos theta minus 2 plus 1, so cos theta minus 1 it becomes cos theta minus 1 plus I sin theta divided by Z plus 2 is cos theta plus I sin theta, correct? This much is given to be equal to 1 by 5. Now we'll multiply and divide by conjugate of denominator. Multiply and divide by cos minus I sin. Then take the imaginary part of that. Imaginary part of, I'll use the short forms here. C as cos, S as sin. So I'll write C minus 1 plus I into S. And if you multiply and divide by cos minus I sin, denominator will become cos square plus sin square, 1. Correct? Numerator, this will get multiplied by cos minus sin. Or I can tell 1 by cos plus I sin is cos minus I sin. So for this I can put a bracket like this. This is multiplied by C minus I into S. So I need to collect the imaginary part of this. Imaginary part is terms with I. C minus 1 into C, I'll get real part. C minus 1 into minus IS, there I'll get imaginary part. So C minus 1 into minus S, I'll write the imaginary part here. C minus 1 into minus S, I'll get the imaginary part. And one more I'll get here, I into SC, that is imaginary part is SC here. This into this, I'll get imaginary part. This into this. This into this I won't get. Correct? Even this into this I won't get. So the imaginary part I collected and wrote is equal to 1 by 5. C into minus S, that is minus CS. Here minus into minus becomes plus sine plus SC. S means sine, C means cos. Minus CS plus CS will cancel out. So I'm getting sine theta as 1 by 5. That is, I'm getting sine theta is equal to 1 by 5. These two will cancel out. Correct? Minus CS plus CS will cancel out. C means cos, S means sine. So sine theta is 1 by 5 I'm getting. So using sine theta equal to 1 by 5, I have to find mod of real part of z plus 2 conjugate. What is z plus 2? Z plus 2 already we have cos theta plus I sin theta, correct? So real part of z plus 2 bar, correct? Z plus 2 is how much? Z plus 2 is here. Z plus 2 is cos theta plus I sin theta. Z plus 2 conjugate is cos theta minus I sin theta, correct? Therefore, since z plus 2 is z plus 2 is equal to cos theta plus I sin theta, z plus 2 bar is going to be cos theta minus I sin theta. Z plus 2 bar, correct? The real part of z plus 2 bar, real part is cos theta. Real part of z plus 2 bar, real part is cos theta. C means cos. Now take modulus for this. If sin theta is 1 by 5, I can find out cos theta is how much? Cos theta is plus or minus root of 1 minus sin square theta. Correct? So plus or minus root of 1 minus sin theta is 1 by 5. Sin square theta is 1 by 25. 1 minus 1 by 25 is 24 by 25. So root of 24 by 25 get. Root of 24 divided by 25 is equal to plus or minus 2 root 6 divided by 5. Cos theta I got. So cos theta is plus or minus 2 root 6 by 5. I want to find mod of real part of z plus 2 conjugate. Take mod of this. Mod of real part of z plus 2 conjugate. Correct? Cos theta is how much? Plus or minus 2 root 6 by 5. Cos theta is plus or minus. When you take mod for this, take mod for this. Mod of plus or minus 2 root 6 by 5 is 2 root 6 by 5. So answer is 2 root 6 divided by 5. Option E. Quite simple question. Use this technique. Mod z is r means we can write z as r into cos plus I sin. So mod z plus 2 is 1. So write z plus 2 as 1 into cos plus I sin. So z will be cos theta minus 2 plus I sin theta. Collect the real part and imaginary part separately. Substitute for z plus 1. Z is cos minus 2 plus I sin theta. So z plus 1 is cos theta minus 2 plus 1 becomes minus 1 plus I sin theta. Z plus 2 right cos theta plus I sin theta. And 1 by cos plus I sin is cos minus I sin. Correct? This is into 1 by cos plus I sin I can consider. 1 by cos plus I sin is cos minus I sin. And collect the imaginary part and write. Minus CS plus CS will add up to 0. Get sin theta is 1 by 5. Then find out cos theta equal to how much. If sin theta is 1 by 5, cos theta is plus or minus root of 1 minus sin square theta using the identity. So I'll get plus or minus 2 root 6 by 5. And want to find this real part of z plus 2 conjugate. Find out z plus 2 real part. Real part of z plus 2 is cos theta. Z plus 2 bar is cos theta minus I sin theta from this. Real part of z plus 2 conjugate is cos theta. Take mod and write the answer. Question asked on 8th of April, first shift, JEE Main 2024. Move on to the next one. Sum of all possible values of theta belonging to this interval, minus pi to 2 pi, for which 1 plus I cos theta by 1 minus 2 I cos theta is purely imaginary. This type of question is also asked many times. Purely real, purely imaginary. Purely real means imaginary part is 0. Purely imaginary means real part should be 0. You bring it to the form of a plus ib and take the real part should be 0. For purely imaginary, find sum of all possible values of theta and this. Your negative angle is also there, positive angle is also there. Both are there. So write the values of theta and take the sum of that. So take the complex number as z. Z is equal to 1 plus I cos theta divided by 1 minus 2I cos theta. Multiply and divide by 1 plus 2i cos theta. Multiply and divide by the conjugate of denominator, where I get real part and equal to 0. Purely imaginary they told. Purely imaginary means real part should be 0. Denominator is a minus b into a plus b, a square minus b square. Denominator is 1 square minus 2i cos theta the whole square. Correct? Denominator a minus b into a plus b, a square minus b square. This 1 square is 1. This is 4i square cos square theta. And use I square as minus 1. So minus of minus becomes plus 1 plus 4 cos square theta. Because I square is minus 1. Denominator is 1 plus 4 cos square theta. Correct? Numerator you write only the real part. Purely imaginary means real part should be 0. Correct? So take the real part and equate it to 0. Z is purely imaginary. Z is purely imaginary implies real part is equal to 0. Real of Z is equal to 0. Where is real part I get? When you multiply numerator denominator, numerator 1 into 1, that is real. Correct? Here I get imaginary. I cos theta into 1 is imaginary. 1 into 2i cos theta, there also I get imaginary part. I into 2i square. 2i square is minus 1. Correct? So here when you multiply 1 to 1, I'll get real part. When you multiply I cos theta into 2i cos theta, I get real part. I into I is I square. Correct? I square is minus 1. So when you multiply I cos theta and 2i cos theta, what I am getting is minus 2 cos square theta. Correct? Divided by what we have? Denominator is 1 plus 4 cos square theta. Numerator by denominator is equal to 0 means numerator should be 0. I wrote only the real part. Okay? 1 into 1 is real. I cos theta into 2i cos theta is real because I into I is I square. I square is minus 1. So I get minus 2 cos square theta. Numerator by denominator is 0. Numerator is 0. Denominator is non-zero. 0 by non-zero is 0. Denominator is non-zero. So numerator should be 0. Correct? 1 minus 2 cos square theta equal to 0. That means cos square theta is equal to 1 by 2 I am getting. Cos square theta is 1 by 2. So cos theta is plus or minus 1 by root 2. Cos theta equal to 1 by root 2 is possible in the first and fourth quadrant. Here positive angle and negative angle is there. 0 to 2 pi is anti-clockwise positive angle. Minus pi to 0 is negative angle. So I should consider both positive angle and negative angle. 0 to 2 pi I get positive angle. Minus pi to 0 is negative angle. Cos theta equal to 1 by root 2 is possible in the first quadrant and fourth quadrant. Theta is equal to pi by 4, first quadrant. And in the fourth quadrant it is 2 pi minus theta. 2 pi minus pi by 4. 2 pi minus pi by 4 is 7 pi by 4. And also negative angle in the clockwise direction. Cos of minus pi by 4. Cos of minus pi by 4 is 1 by root 2. Cos theta is minus 1 by root 2 is possible. Cos theta is minus 1 by root 2 is possible in the second and third quadrant. Cos 3 pi by 4 is minus 1 by root 2. Cos 135 degree. And cos 5 pi by 4 is also minus 1 by root 2. Cos is negative in the second and third quadrant. This is positive angle I wrote, which covers in the interval 0 to 2 pi. Correct? Which covers the positive cycle 0 to 2 pi. And in the interval minus pi to 0, cos function is negative in the third quadrant. That is possible for theta is equal to minus 3 pi by 4. Correct? Minus 3 pi by 4. 0 to 2 pi is like this. If you want to represent here, if you want 0 to 2 pi is like this. 0 to 2 pi. First quadrant, second quadrant, third quadrant and fourth quadrant. Cos function is positive in the first and fourth quadrant. First quadrant theta is pi by 4. Fourth quadrant it is 2 pi minus pi by 4. 2 pi minus pi by 4 is 7 pi by 4. And this is minus pi by 4. That is for clockwise negative angle like this. Where it is This is minus pi. This is minus pi by 2, 0. This is in the third quadrant and in the fourth quadrant. This is 0 to 2 pi, 0, pi by 2, pi, 3 pi by 2 and 2 pi. 0 to 2 pi, anti-clockwise, positive angle, and minus pi to 0 in the clockwise direction. Here one negative angle is possible, that is minus 3 pi by 4. 0, minus pi by 2, minus pi. So write the values of theta, where cos theta is 1 by root 2, 3 values I am getting. Cos theta minus 1 by root 2, so I get 3 values. They ask to find sum of all possible values of theta. Therefore, sum of all possible values. Sum of all possible values of theta. Learn to write the values of trigonometric functions using allied angles. Sum of all possible values. Here add all these things. Pi by 4 minus pi by 4 added to 0. 7 pi by 4. Here 3 pi by 4 will cancel. 7 pi by 4 plus 5 pi by 4. 12 pi by 4. That is 3 pi. Correct? If you add all these things, pi by 4 plus 7 pi by 4 plus minus pi by 4 plus 3 pi by 4 plus 5 pi by 4 plus minus 3 pi by 4. Sum of all these things. Pi by 4 will cancel, 3 pi by 4 will cancel. So finally get 7 pi by 4 plus, sorry, this is 5 pi by 4, no? Yeah, these will cancel, 3 pi will cancel, 7 pi by 4 plus 5 pi by 4, that is 12 pi by 4. 12 pi by 4. These will cancel, these will cancel, correct? 7 pi by 4 plus 5 pi by 4, 12 pi by 4, which is equal to 3 pi. So answer is option E. Quite a simple question. Many times this type of question is asked. Minimum 3 to 4 times. If you see all the previous set questions, not only of this 2023, 22, 21 like that. See all the papers and see this type of question. Minimum 3 to 4 times they have asked. Okay. So very similar kind of questions are asked. Many times questions do repeat. Okay. Question asked on 8th of April, second shift, JEE Main 2024. Move on to the next one. Sum of the square of the modulus of the elements in this set. It's a geometrical representation kind of question. Mod of z minus 1 less than or equal to 1. And mod z minus 5 less than or equal to mod z minus 5i. Mod z minus 1 less than or equal to 1 represents what? Circle having center at 1, 0 and radius 1. Points on the circle and interior to circle. Correct? Points on the circle and interior to circle. Points on the circle and interior to circle. Interior to the circle. With center at 1, 0 and radius 1. With center at 1, 0 and radius is 1 unit. And mod z minus 5 less than or equal to mod z minus 5 and solve that. Also mod z minus 5 is less than or equal to mod of z minus 5i. Z is what? Z is x plus iy tech. X plus iy minus 5 less than or equal to. Z is x plus iy minus 5i. This will be equal to what? Mod of x minus 5 plus iy less than or equal. This is mod of x plus I into y minus 5. Modulus is what? Root of x square plus y square. Root of x minus 5 the whole square plus y square. Here root of what we have? X square plus y minus 5 the whole square. Squaring on both sides. What we get? X minus 5 the whole square plus y square less than or equal to. Here it will be x square plus y minus 5 the whole square. Simplify this. X square plus 25 minus 10x plus y square less than or equal to x square plus y square plus 25 minus 10y. X square plus y square will cancel. 25 cancels. What I am getting is minus 10x is less than or equal to minus 10y. Identical terms will cancel from left hand side and right hand side, correct? And we can multiply the inequation by minus 10. What I am going to get is x is greater than or equal to y. When you multiply by negative number, inequality is going to reverse. Multiply by divide by minus 10. Same as telling multiply by minus 1 by 10, correct? Inequality is going to reverse. I am getting x greater than or equal to y. So I need to find number of elements in this set. Then you can find out sum of the squares of the modulus. A and B are integers. Complex numbers takes the form a plus ib, where a and b are integers, z. So we'll represent this. This is circle, points on the circle and interior to circle, having center at 1, 0, radius 1. Points on the circle and interior to circle, having center at 1, 0 and radius is 1. Center at 1, 0 and radius is 1. Radius is 1 means one end of the diameter is 0, 0, other end is 2, 0, something like this. Circle is having center at 1, 0, radius is 1. Points on the circle and interior to circle. That is the first one. Second one I am getting like this. X greater than or equal to y. X equal to y is a straight line passing through the origin. Like this. X equal to y is the straight line passing through the origin. X equal to y. X greater than or equal to y is above the line. Okay. If you want to take x equal to 1 and y equal to 0, 1 greater than or equal to 0. 1, 0 lies above the line, correct? In the upper half, lower half and upper half I can call. 1, 0 if you substitute, 1, 0 clearly lies in the upper half, correct? Put x equal to 1, y equal to 0. 1 greater than or equal to 0 is true, therefore your region is upper half. So I want to find the number of elements in this set common to these two. Common to these two is circle is inside the circle and on the circle, and the line is above the line. So common to these two to this. This is a region common to this. This is 1, 0. It can represent using some other ink. You should write the complex numbers in this set where z is a plus ib, a and b are integers. How many complex numbers lies in this region with a and b integers? A plus ib is a complex number with a and b integers. 0, I can use 0, 0, right? 0, 0 I can use. 0, 0 is one complex number. 0 plus I into 0, one complex number is there. This also I can take 1, 0, correct? 1 plus I into 0 with a and b integers. I should write the complex numbers in this region with complex number as a plus ib with a and b integers. 0, 0 lies. 1, 0 lies. This is 2, 0 because radius is 1, no? 2 plus I into 0 lies. This point is 2, 0. 2, 0 lies. Then which one is going to lie in this region? This point lies, no? This point is how much? If we solve the equation, x is, if we solve this equation, x is greater than or equal to y. If you put x equal to y, what I am going to get? Solve the two equations. Put x equal to y in the equation of circle. You get the points of intersection. What are the points of intersection you find out? This point I can find out, and one point is origin, the point of intersection. If you put x equal to y, the Cartesian form of the equation of circle is what? The Cartesian form of the equation of circle is x minus 1 the whole square plus y minus 0 the whole square, y square is equal to 1. Correct? If you put x equal to y, I'll get x square plus 1 minus 2x. Y is same as x equal to 1. Correct? I'll get 2x square minus 2x equal to 0. That means 2x is common. X minus 1 equal to 0. That means x equal to 0, x equal to 1. X equal to 0 means y will be 0. X equal to 1, y equal to 1. So 0 comma 0 is 1 point. Another point is this. This point is 1 comma 0, 1 comma 1. So my points of intersection will be, one is this, 0 comma 0. Another point of intersection is 1 comma 1. 1 comma 1. Oh, I had drawn the line wrong, I think. Sorry. I had drawn x equal to y as line passing through second and third quadrant. Second and fourth quadrant. Sorry, mistake I've done. My representation of the line is wrong. Y is equal to x is how? Y is equal to x is straight line passing through the origin bisects the first and third quadrant, right? Small mistake I've done here. Y is equal to x is the straight line passing through the origin like this. This is a line, y is equal to x. Y is equal to x. We want x greater than or equal to y. X greater than or equal to y is the region which is common to these two. I'll do it from the beginning here, this part. Small mistake has happened here, sorry. Circle was having center at 1 comma 0 and radius is 1, correct? That is this. Circle with center 1 comma 0 and radius is 1. And the line y equal to x is what? Straight line passing through the origin which bisects the first and third quadrant. I have drawn the other way. Sorry, by mistake it was. Y is equal to x. We want x greater than or equal to y. If you take 1 comma 0, it satisfies, correct? 1 is greater than or equal to 0 is true. That means your region is towards the point 1 comma 0. The line x greater than or equal to y will be coming downwards and it is inside the circle. So this is a common region. This is a common region for this. Correct? So which are the complex numbers lying in this? Complex number in the form of a plus ib lying in this with a and b are integers. So which are the complex numbers satisfying that you can find out. And also I got the point of intersection. When x is 0, y is 0. X is 0, y is 0. When x is 1, y is 1. These are the points of intersection of the line and the circle. 0 comma 0 is here and this point is 1 comma 1. 1 comma 1. And this point will be 2 comma 0. And this point will be minus 1 comma 0. Correct? My line is not exactly correct. I can draw the better line if you want. You can draw a line which is a little bit more proper figure. Y is equal to x. Y is equal to x is something like this. This point is 1 comma 1. This point is 1 comma 1. Okay, y is equal to x. This is your region. In this region you are finding out. And this point is 1 comma 0. This point will be minus 1 comma 0. So I should find the number of complex numbers lying in this region. A plus ib is a complex number with a and b integers. So which are the possible values? One is 0 plus I into 0, one complex number. Correct? 1 plus I into 0, that is another complex number. 2 plus I into 0, I'll write here. 2 plus I into 0. 1 plus I into 1. 1 plus I into 1, correct? And this is minus 1 comma, sorry, this is not minus 1 comma 0. This should be x, so x equal to 1, y is equal to minus 1. X equal to 1, y equal to minus 1. It's lying in the fourth quadrant, no? The point is in the fourth quadrant, this point. So x is 1, it's a vertical line, y will be minus 1. Correct? 1 comma minus 1. These are the complex numbers we have. Totally we have 5 complex numbers. Correct? 1, 2, 3, 4, 5. 1 plus I into 1. Lastly, we have 1 plus I into minus 1. Totally, we have 5 complex numbers. So, what is modulus of this? Modulus of this is 0. Modulus of this is 1. Modulus of this is 2. Modulus of this is root 2. Modulus of this is root 2. I should find sum of the squares of the modulus. Take the squares of this and take the sum of this. Therefore, sum of the square of the modulus is 1 is 0 square, 0. Correct? Sum of the squares of the modulus. Zero square plus 1 square 1 plus 2 square, that is 4. Here root 2 square, that is 2, and again root 2 square 2. 2 plus 2 4, 4 plus 4 8 plus 1 9. 9 is answer. Sum of the squares of the modulus of all the complex numbers lying in this region with a and b integers. A plus ib is a complex number with a and b integers. Totally we have 5 complex numbers. 0, 0, that is 0 plus I into 0. 1, 0, 1 plus I into 0. 2, 0, that is 2 plus I into 0. 1, 1, that is 1 plus I into 1. Last we have 1, minus 1, which is 1 plus I into minus 1. Find the modulus for all these things and take the squares of that and add it. 0 square plus 1 square plus 2 square plus root 2 square plus root 2 square. We'll get the answer to this. Sum of the square of the modulus of the elements lying in this. Complex number is a plus ib with a and b integers. I made a small mistake while drawing the figure or line y equal to x. I drew it like this. It was wrong. So I made a correction. Could get the point of intersection and represent the points. Okay. Question asked on 9th of April, first shift, JEE Main 2024. Move on to the next one. Question number 9. Z be a complex number such that real part of this is 0. Want to find the maximum value of this. Mod of z minus of 6 plus 8i. Real part of this complex number is 0. Real part of the complex number is 0 means the complex number is purely imaginary. Correct? Real part of some complex number is equal to 0 means the complex number w is purely imaginary. Purely imaginary. Correct? Real part of the complex number is 0 means the complex number is purely imaginary. So this complex number, real part is 0. That means it is purely imaginary. If w is purely imaginary, you can write w equal to minus w bar. You must know this. If a complex number w is purely imaginary, I can use this technique of solving the problem. Whenever they mention that complex number is purely imaginary, we can write w is equal to minus w bar. Purely imaginary. So real part of this is 0 means the complex number is purely imaginary. Complex number is purely imaginary means I can use this concept. Write the complex number equal to negative of the conjugate. So z, real part of this is 0. Real part of this expression is 0. Real part of z minus 2i divided by z plus 2i is equal to 0. Real part of this is 0. That means z minus 2i divided by z plus 2i is purely imaginary. Is purely imaginary. Purely imaginary means what? I'll use this concept. Write the complex number equal to negative of its conjugate. Z minus 2i by z plus 2i is equal to negative of its conjugate. Conjugate is what? Z bar. Conjugate of minus 2i will be plus 2i divided by z becomes z bar. 2i becomes minus 2i. Cross multiply this. Z minus 2i into z bar minus 2i is equal to minus of z plus 2i, cross multiply, z plus 2i into z bar plus 2i, cross multiply, crisscross. Okay. Simplify this. Multiply 1 by 1. What do you get? Z into Z bar minus 2I Z bar minus 2IZ minus 2I into minus 2I plus 4I square. 4I square is minus 4. Here minus Z into Z bar minus 2IZ bar minus 2IZ minus 4I square. 4I square is minus 4. Minus of minus 4 becomes plus 4. 4I square minus 4 minus of minus plus 4. Identical terms will cancel. Minus 2IZ bar minus 2IZ bar will cancel. Minus 2IZ will cancel. These will cancel. These two will cancel. So what is left? ZZ bar plus ZZ bar. 2 times Z into Z bar. 2 times Z into Z bar is equal to 4 plus 4, 8. From this we can write Z into Z bar is equal to 4. Z into Z bar is mod Z square using the properties. So mod Z square is equal to 4. Mod Z square is equal to 4 means mod Z is equal to 2. 200 plus or minus 2. Modulus can't be negative. So mod Z is 2 I'm getting. Mod Z is 2 means what? It represents a circle with center at origin. Radius is 2. So it represents a circle with center at origin and radius is 2. Mod Z is equal to 2 represents a circle with center at origin, radius equal to 2. Okay. Want to find the maximum value of mod of Z minus 6 plus 8i. So you have to find the maximum distance. Mod of Z minus Z1 represents a distance between Z and Z1. So mod of Z minus 6 plus 8i represents distance between Z and the point 6, 8. Z is any point on this circle. Correct? So Z is a complex number satisfying this. It lies on this circle having center at origin, radius 2. So want to find the distance, maximum distance between the point on the circle and this point 6, 8. 6, 8 is somewhere here. So when is the distance between the point P and the point on the circle becomes maximum? That is, I take the maximum distance along the diameter. This happens to be the maximum distance. So find out OP plus radius. Radius of the circle already we know 2. So maximum distance, maximum value of this is nothing but maximum distance between the point 6, 8 and the point on the circle. Distance between 6, 8 and the point on the circle is maximum along this. So find out OP plus radius. So required is maximum value of mod of Z minus of 6 plus 8i is nothing but OP plus radius as shown the maximum distance. This is the maximum distance. OP plus the radius of the circle. OP distance between the points origin and the point 6, 8, that is root of 6 minus 0 the whole square plus 8 minus 0 the whole square. 6 square plus 8 square, that is root 100, which is 10. OP is 10. And radius of the circle is already we know 2. Correct? Mod Z equal to 2. Radius of the circle is 2. So 10 plus 2 is 12. So maximum value is 12. Mod of Z minus Z1 represents distance between the point Z and Z1. Want to find maximum value of this means you have to find maximum distance between Z and 6, 8. Z is any point on this circle. Where the distance becomes maximum? When it is here. Correct? In short, PQ. PQ is the maximum I can call. PQ is maximum. PQ is OP plus OQ. OP you can find out by using distance formula. OQ is the radius. So 10 plus 2, 12 is the answer. Question asked on 9th of April, second shift, JEE Main 2024. Move on to the next one. This is the last question, I think, of this complex numbers of 2024 April shift. Okay. R is given as A comma B with A plus 5B equal to 42. A and B are natural numbers has m elements and summation n equal to 1 to m 1 minus I power n factorial equal to x plus I y, where I is root of minus 1. Find the value of m plus x plus y. A plus 5b is 42 the given. A plus 5b is 42. A and B both are natural numbers. So we'll start with A plus 5b equal to 42. a plus 5b is equal to 42. From this, I can write this as 5b is equal to 5b is 42 minus a, or a is 42 minus 5. A is 42 minus 5b. Both a and b are natural numbers. Which are the values possible to take? You can start b equal to 1. When b is 1, when b is equal to 1, a is equal to how much? 42 minus 5, 37. Possible. When b is equal to 2, when b is equal to 2, a becomes 42 minus 10, which is 32. When b equal to 3, a is equal to how much? 42 minus 15, that is 27. When b equal to 4, a is equal to 22, I am getting. Correct? 5 into 4, 20. 42 minus 20, which is 22. When b equal to 5, a is equal to 5 into 5 is 25. 42 minus 25 is 17. When b equal to 6, when b is equal to 6, a is equal to how much? 5 into 6 is 30. 42 minus 30 is 12. When b equal to 7, a is equal to how much? 5 into 7, 35. 42 minus 35, which is 7. When b equal to 8, a is equal to how much? 5 into 8 is 40. 42 minus 40 is 2. Next value is not possible. When you put b equal to 9, no, I'll get a as negative, which is not a natural number. So how many ordered pairs are there? 8 ordered pairs are there. Correct? 8 ordered pairs. So number of ordered pairs satisfying this equation with a and b are natural numbers is 8. So m is equal to 8, I can tell. M is equal to 8. And that m I need to substitute here. N factorial is there. Summation n is equal to 1 to m. Summation n is equal to 1 to m. M we got 8. M we got 8. 8. 1 minus I to the power n factorial. That means what? 1 minus, this is 1 minus I to the power, 1 factorial is 1, plus 1 minus I to the power 2 factorial is 2, plus 1 minus I to the power 3 factorial, that is 6. Next, 1 minus I to the power 4 factorial, that is 24. Next is 1 minus I to the power 5 factorial, that is 120. 1 minus I to the power 6 factorial, that is 720. Correct? Plus 1 minus I to the power 7 factorial, that is 5040. Plus lastly we have 1 minus I to the power 8 factorial, that is 40,320. You know that from 24 onwards, from 4 factorial onwards, everything is multiple of 4. 4 factorial, 5 factorial, 6 factorial, 7 factorial, 8 factorial, all are multiples of 4. We know I to the power multiples of 4 is 1, correct? We know that 4 factorial, 5 factorial, 6 factorial, etc. all are multiples of 4. All are multiples of 4. And you must know that I to the power multiple of 4 is 1. For all n belongs to integers, in fact. I to the power multiple of 4 is 1. So I power 4 factorial is 1. I power 24 is 1. I power 120 is 1. So 1 minus 1 becomes 0. This part is 0. Even this is 0. Because I power 120 is 1. 1 minus 1, 0. Even this is 0. This is 0. This is 0. What is left is 1 minus I. Here I square is minus 1. 1 minus minus 1, 2. Here I power 6 is same as I square. I power 6 is equal to I power 4 into I square. I power 4 is 1, I square is minus 1, so we get minus 1. I power 6 is minus 1, 1 minus minus 1, 2. Rest all zeros because 4 factorial onwards, everything is multiple of 4. And I to the power multiple of 4 is 1. So each of these brackets becomes 1 minus 1, 0, 1 minus 1, 0, 1 minus 1, 0, 1 minus 1, 0, 1 minus 1, 0. Rest all zeros. So what I am getting is 5 minus I. This you can compare with x plus iy. If we compare, we get x is equal to 5 and y is equal to minus 1. What we need to find is m plus x plus y. We need to find m plus x plus y. Therefore, finally write the answer. M plus x plus y is equal to how much? M we got 8. X we got 5 and y is minus 1. 5 plus minus 1. 5 plus minus 1, 4. 4 plus 8 is 12. Answer is 12. Question answered on 8th of April, first shift, JEE Main 2024. With this, all the 10 questions of JEE Main 2024 April shift of complex numbers is completely solved. Okay. So, this is our 10th question on algebra of complex numbers. Quite a simple one. Find the number of ordered pairs A, B, satisfying this with A and B natural numbers. That is 8 I got. That 8 you have to substitute here. M is equal to 8. N equal to 1 to 8. Substitute. 1 factorial, 2 factorial, all those things. I to the power multiple of 4 is 1 for all n belongs to integers, we know. Correct? And this was the 9th question on geometrical representation of a complex number. PQ is maximum. So find the maximum distance using. And this was one question based on geometrical figure. I made a small mistake while drawing the figure. Y is equal to x. I represent like this. I made a correction myself without anybody's help. Y is equal to x is straight line passing through the origin, bisects the first and third quadrant. I drew it like this in the third and fourth quadrant, second and fourth quadrant, and then I made a correction and we got 5 points in this region with A and B integers. A plus I is a complex number, A and B integers. Such complex number there are 5. Take the modulus of that and take the square of that and add it. Sum of the square of the modulus of the elements present in that region, A and B are integers. Such complex numbers to take. And 7th one, this is a commonly asked question. Many times we can find this kind of question. Okay. And this is also based on the properties of modulus and conjugate, etc. This is one more result we had, one of the standard result. If you use this result, you can solve the question in very less time. Okay. Learn this result. Even in CET exams, this type of question is asked many times. This is the 4th question, again on the geometrical representation. And this is on triangle inequality, modulus concept. Another question on geometrical representation, and this was on solving the equation using the modulus and conjugate. Altogether we had 10 questions. No questions are asked from De Moivre's theorem and cube roots of infinity, etc. And this is of April shift, complex numbers, JEE Main 2024. All the questions is completed. Many more videos will be uploaded in the coming days focusing on KCT PYQs from 1984 to 2025 of some chapters, and which are new chapters which are not there earlier. We'll do the CET from 2014 to 2025, and also synopsis for KCT, synopsis for JEE exams, and also PYQs of JEE Mains 2024 and 25. We covered everything in detail. With this, I conclude. Thank you.